Hey everybody, this is Mr. Beckstrom, and today we're going to be talking about Chapter 1, Section 1. This is on ratio, proportion, and percent. So let's go ahead and get started. First, we're going to take a look at what a ratio is and look at some examples of how we use ratios. So just reading from here, a ratio is a comparison using division of two quantities of the same kind, both expressed in the same units. So there's a couple of requirements that we have here, and we're actually going to do a problem a little bit later where we're going to have to do a conversion on the units in order to get them to be the same. So this is what a ratio is. Here's some common ratios that they use in Chapter 1, Section 1. This is a gear ratio. This is the number of teeth on the driven gear over the number of teeth on the driving gear. You have a compression ratio. Once again, these are kind of automotive or welding terms. This is the expanded volume over the compressed volume. And then we have the pitch, which you may have heard that term being used, like the pitch of a roof. And that is the rise over the run, or the vertical distance over the horizontal distance of that roof. So let's go ahead and look at an example here. So what is the pitch of the following roof? So go ahead, you can pause the video here and look back to see the formula and see if you can get that. So what we do is we have the rise over the run. Remember, the rise is the vertical distance. That's going to be the 15 feet. The run is the 30 feet. Now make sure you don't get confused and use the entire distance across, because that includes the distance that it goes up and it goes down. We only want the distance where this roof is increasing. So once it stops increasing in height, that's when we want to stop our length here, or our run. So you should have gotten 15 feet is the rise, 30 feet is the run. The feet units will cancel out, and we can reduce that 15 over 30 to 1/2. All right. So let's take a look at another example here, and we'll look at another way of stating a ratio, and we'll see that in just a minute. But a diesel engine has a maximum cylinder volume of 55 cubic inches and a compressed volume of 5.0 cubic inches. What is the compression ratio? So going back up to the compression ratio, we know that's the expanded or maximum volume over the compressed volume. So go ahead and pause it and see if you can get that. And then we'll look at that. All right, go to the next screen here. The expanded or maximum volume was 55 cubic inches. The compressed volume is 5 cubic inches. Once again, those units will kind of cancel out and it'll just give us our ratio with no units, which is 11 over 1. And we often write this, and some ratios are more standard than others, but we can either write this as 11 over 1 or 11 to 1. If you ever see it in this form here, you put the first number over the second number. So the first number's on top, the second number's on bottom of that ratio. All right, moving on. Proportion. So once we understand what the ratio is, a proportion is just stating that two ratios are equal to each other. So A, B, C, and D, these all represent some types of quantities or values. And in order to be a proportion, A over B has to equal C over D. So I'll give an example of 3/4 and 6/8. Hopefully you can kind of see that those are the same quantities. If you were going to divide up a circle in 4 equal parts and take 3 of them, that's going to be the same amount of space in that circle as if you were to divide that same circle in 8 different parts and just looked at the area of 6 of them. So it's kind of a visual way to see these proportions. All right, so let's look at the cross product rule. And a lot of you may have seen this before. Hopefully you've seen it somewhere in school. Usually start looking at this in middle school, and you do some in high school. But this is the cross product rule, and where we're going to multiply these values or quantities in a diagonal fashion. So if we have two ratios that are equal to each other, then if we take the diagonal product, so A times D, that's going to have to equal B times C. And this is a really useful procedure for us to be able to use, because we're going to solve a whole lot of different problems using this cross product rule. So make sure that you're real familiar with it and you look at some of the examples in the book and the homework, and if you have any questions, let me know. So verify that the following proportion is true using the cross product rule. So if we have two ratios and they're set equal, how do we verify that this is actually a proportion, that these two ratios are equal to each other? Well, we can actually verify that using the cross product rule, because when we cross multiply, 5 times 9 should equal 3 times 15. If it's not, then this is not a valid proportion, because then those two ratios are not equal. So in this case, 5 times 9 is 45, and 3 times 15 is also 45. Since they're the same quantity, when you multiply those diagonals, then the proportion is true, and you actually have a proportion. All right, so let's use the cross product rule to solve for a variable. So let's say we have 3 out of the 4 quantities in a proportion. We can use that cross product in order to solve. Hopefully you've seen some of this before. If you haven't, or you have any trouble, once again, just let me know. But if we set up our proportion, then we cross multiply 3 times 40, that's our 120. And we set the equal sign, and 10 times x is 10x. That's just stating 10 times x. It doesn't matter which side you have the 10x on. You could have it on the other side. You could have the 120 on this side. As long as the equal sign is in between those, we should be good. Then we just divide both sides by 10 in order to get this x by itself, because 10 times something divided by 10 just leaves you that something, or in this case, the variable. So 10x divided by 10 just gives you x, and 120 divided by 10 gives you 12. So in this case, x is equal to 12. All right, and last example here. You go ahead and try this one. Solve for the missing value, and go ahead and pause it and see if you're doing it correctly. All right, and so we're going to use the cross multiplication on that proportion there. We notice that 16 times x is 16x, 9 times 64 is 576. We want to get that 16 by itself. Since we're multiplying by 16, we need to divide by 16. It's usually the opposite operation in order to get those variables by themselves. And in this case, 16x divided by 16 is x, and 576 divided by 16 is 36. So the missing quantity in this proportion is 36. All right, that's it. If you have any questions, go ahead and give me a call or shoot me an email. All of my contact information is on the Moodle main webpage there. And thank you, and have a great day or evening.